All right, let's dive in. Every single time you use your phone, your tablet, your computer, there's this incredible, totally invisible process that just kicks into gear. Today, we're going to pull back that curtain and look at the fundamental journey that powers your entire digital world. And it all starts with just a single tap.
So, think about it. It all begins with something so simple, right? You see a link a friend sent you, you tap it, and boom, like magic, a video starts playing. But what actually happens in that split second between your touch and the result? Well, that's the journey we're about to take.
You know, this whole complicated process can actually be broken down into 4 core steps. These 4 steps have powered computing for decades. So think of this as our roadmap for today. First, there's input. That's you giving a command. Then, processing. The device thinks about it. Next is storage. It might need to save something. And finally, output. It shows you the result. Simple as that.
So let's begin right at the beginning, where it all starts, with you. See, every digital journey, no matter how complex it seems, is basically just sitting there waiting for you to give the first command.
That simple tap on a YouTube link, that is the starting gun. You've just given the computer its first piece of information, the first command in a whole chain of events. And in the world of computing, we call this an input.
What's so cool is how much our methods for giving that input have changed. I mean, think back to the 70s. It was all about typing these precise text commands on a keyboard. Then the 80s brought us the mouse, which made everything graphical and way more intuitive. And now? Well, now we just talk to our devices. We touch them. We even wave at them. You know, there's this classic saying in computing, garbage in, garbage out. And it perfectly explains a core truth. A computer is only as good as the instructions you give it. If you give it clear, correct input, you get the right result. But if the input is messy or wrong, well, the output is going to be just as flawed. It all comes back to the quality of that first command.
Okay, so you've given your command. Now what? Well, the device has to actually understand it. And this brings us to step 2, processing. This is the brains of the whole operation. Your instruction zips straight to the central processing unit, the CPU. This thing is the heart and brain of your device, and it is ridiculously fast. While it's figuring out how to load your video, it's also checking for new emails, managing your Wi-Fi connection, and running dozens of other tasks in the background. And it does all this in a nanosecond. That's a billionth of a second.
But the CPU doesn't work alone. It needs a workspace. And that's where random access memory, or RAM, comes in. The best way to think of RAM is like a temporary shelf. When the CPU needs to work on that YouTube video, it puts the app and the video data on this shelf for super quick access. But, and this is key, this shelf is volatile. That means as soon as you turn the power off, everything on it gets wiped completely clean.
Now, this is a point of confusion for a lot of people, so let's make it really clear. RAM is the fast, temporary shelf for what you're doing right now. Storage, on the other hand, is the long-term box where you keep everything, your apps, your photos, your files, even when the device is turned off. It's your active workspace versus your permanent library.
And speaking of the library, that brings us perfectly to our third step, storage. This is where your device holds onto information for the long haul.
Let's go back to our YouTube video for a second. While that video is playing, it's living on that temporary RAM shelf. But the moment you hit download to watch it later, the computer moves that file from the shelf into the permanent storage box. Now it's saved. It'll be there the next time you turn on your phone, and the time after that. So what is this box exactly? Well, inside most computers, it's either an older hard disk drive, or HDD, which has these spinning magnetic disks, or it's a modern solid-state drive, an SSD, that uses flash memory. And really, the biggest difference comes down to speed and durability. Because SSDs have 0 moving parts, they are way faster and a lot more reliable. Of course, that permanent box isn't always stuck inside your computer, right? We use portable options like USB flash drives, we rely on huge external hard disks, and more, we just store our files in the cloud. And yeah, even though they're kind of fading out, optical disks like CDs and DVDs are still a form of storage.
Okay, so we've given the input, the device has processed it, and it's using both its temporary memory and its long-term storage. We've officially reached the final step, getting the result back to you.
And here it is, the end of the journey. The CPU has done its job and it sends the result back to you in a form that you can actually understand. This is output. And for our YouTube example, that's the video appearing on your screen and the sound playing from your speakers. The command is complete.
And output is so much more than just what you see and hear. Think about it for a sec. A document that comes out of a printer? That's output. A physical model made by a 3D printer? Also output. Even the voice giving you turn-by-turn directions from your GPS is a form of output. It's really any way the computer presents its results back to the world.
So there you have it. Input, processing, storage, and output. From that one simple tap all the way to a video playing on your screen, you've just witnessed the entire cycle. This simple 4-step journey is the fundamental engine humming away inside every single digital device we use.
But here's the part that is just absolutely mind-blowing. How many times can a modern computer run through that entire 4-step cycle? It can do it billions of times, every single second. It's a speed that's almost impossible to wrap your head around, and it's what makes our entire digital life possible. What's really amazing is that this elegant 4-step cycle has been the bedrock of computing for over half a century. It's proven to be incredibly resilient, incredibly adaptable. And so that leaves us with one last really fascinating question to think about. After all this time, what kind of technological leap would it take to finally, fundamentally change it?